Hello everyone, it's Mr. Wolfe here, and in this video I am going to be introducing word problems for our Unit 2 on forces, specifically how to solve multi-step problems. So let's just dive into an example. So problem 1 right here, a 10,000 kilograms, so right away I see these units, kilograms. I'm going to identify that as mass. So a 10,000 kilogram SpaceX rocket is launching into the air with an increasing speed while its rockets provide an upward force of 250,000 newtons. What is the net force on the SpaceX rocket? So I'm going to start by drawing a free body diagram, and then I'm going to use my target sheet to help me out. So are there any strings or cables? No. Am I on Earth? Yep. Even though the rocket's in the air, it's still on Earth, around Earth. So force of gravity. Is there a surface in contact with the object? It's launching into the air, so no. Is there a surface in contact that would be resisting its motion? Again, no. And is there anything else in contact with it that's pulling or pushing it? Technically, nothing else is in contact with it, but by the rockets exerting gas out of the back of the rocket, it exerts a pushing force on the rocket. All right, and I know to make this force bigger because it says that it's going at an increasing speed. So I know that it's going upwards, and that if it's increasing speeds, its acceleration is going upwards, which means that its net force would also have to be going upwards. All right, so if I'm going to draw my F net x equation, there's no forces going in my x direction, so just 0. But then for my F net y, it's your positive forces minus your negative forces, so upward force, my push force, minus my downward force, force of gravity. All right, so now we're going to just use these bullet points, which are really just getting more specific to our general problem solving steps up here. So what am I solving for? What am I solving for? In this case, I'm solving for my net force, so F net. Okay. And then draw a picture and write down your known variables. We drew a picture, so now let's write down our known variables by looking at the problem. Sometimes they're explicitly stated. Other times we have to use physics concepts to read more into the problem. So in this case, a 10,000 kilogram rocket, so that's going to be my mass. So M equals 10,000 kilograms. All right. And then with an increasing speed while its rockets provide an upward force, so that's going to be my push force, so 250,000 newtons I'll draw right here, but I'll also put it here as well, force push, 250,000 newtons. And there's nothing here about my initial velocity because it's already moving up. It looks like that's all my knowns right now. So then, what equation will I use to solve this problem? Well, if I look at my equations, which ones have my net force, F net? These two right here. So I could use either one of those. So let's write down both. F net is equal to like the sum of the forces, or F net equals MA. All right. And it looks like I could possibly use both of these right now because I have my mass, I don't have acceleration, I have my force push, but I don't have my force of gravity. But if I look up here, if I wanted to use this equation and find acceleration, there's really no other forces, no other equations where I could really find that. All right. But in terms of, even though I don't have my force of gravity, there's another equation that will allow me to use this. So in terms of what equation I'm going to use, at the end of the day, I'm going to use this equation to solve. All right. So what other variables do you need to solve this equation? All right. And what other equation could you use to solve this? All right. So the first thing I'm going to do is I'm just going to write out the full equation, which is really just this one right here. So at the end of the day, I am going to use F net y is equal to force push minus my force of gravity, again, to find my net force. Okay. Now, I have my force push. All right. I'm solving for F net y, but I don't have my force of gravity right now. All right. But if I look at my equations here, there's another equation that I could use to solve for my force of gravity. So that's what I'm going to do. And that's exactly what this is saying. Again, is what other variable don't you have? Force of gravity. And what other equation could you use to solve it? So I'm going to use Fg equals mg. All right. So if I use Fg equals mg here, I'm solving for my force of gravity first. And my mass, again, I already know that. That's 10,000 newtons. Kilograms, right? And then G, right, is always given to us. It's 9.8 newtons per kilogram. That's our gravitational field strength. So 9.8. And when you do the math on this, we get 98,000 newtons. We know that's going downwards. Okay. So remember, at the end of the day, I'm trying to find my net force. So what I'm going to do is now I'm going to take this 98,000 newtons and I'm going to plug it in to the equation that I'm going to use at the end of the day. Right? So 98,000. And then my force push, again, is one of my knowns. So that's 250,000 newtons. Right. And that's equal to my net force, which is what I'm solving for. Right. So then when I do the math on this, 250,000 minus 98,000, that's going to give me a net force of 152,000 newtons. And again, that net force is going upwards conceptually and then also mathematically. And I've solved my problem. All right. So again, a big takeaway here is we first just looked at what we were solving. We looked at our knowns. We looked at what equation we're going to solve at the end of the day. All right, and I wrote down what I knew from it, and even though I didn't have all the variables like force of gravity, I could use other equations to solve for that variable, plug it back into the equation, and then solve for what I'm looking for at the end of the day, which was my net force.